50% of the teacher's desk is covered with exams. What is the probability of spilling coffee on one of those? Half and half? Come on, you guys. This is good stuff. I told you they don't get any better. So this section, 11.3, is all about sector area and sector length, okay? A sector is just a circle is just a region that's formed by two radii and then the arc, okay? So it's like a pie slice, this pie slice here. The area of a sector is just simply a fractional part of the circle, all right? So if I want to find the area of this here, just like if I want to find the area of a pie piece, it's just a fractional part of this whole circle here. So like I said, it's a fractional part. So if I take the area of the circle, and then I take the fractional part of it, remember the circle is a whole 360 degrees, it's going to be a fractional part, the measure of the angle over 360 of the whole thing, the pi r squared. So using this formula, if I want to find the area of the sector in terms of pi and the nearest hundredth of sector HGJ, this sector right here, I'm going to use this formula. I've got the area as being the measure over 360, that's how much of the whole circle, times the whole area itself, plug in what you know. I know that the measure of the angle right here is 131 times, over 360, and I know that my radius right here is 12. All right, so you're going to take and you're going to do 12 squared times 131. So it's 144 times 131, and then divide it by 360. If you do this, you get 52.4 pi, and then don't forget, it's going to be meters squared. Now that's in terms of pi. If I wanted to the nearest hundredth, just multiply through by pi, and you get 164.62 meters squared. All right, so one more time, you're going to take the top numbers, 12 squared, so it's 144 times 131, and then divide it by 360. That's where I get the 52.4 from. Then, to find it's the nearest hundredth, you multiply through by pi. All right, so I want you to do this one. Find the area of the sector. Here it is. The degree is 25. The degree is 25, and the radius is 5. So figure this out, pause it, and then come back. We'll see if we have the same answer. All right, so my degree is 25. That's there. My radius is 5. That's there. So you take 5 squared, which is 25. So 25 times 25, and divide it by 360. That gives you 1.74, and then your pi. And then to the nearest hundredth, you multiply through by the pi, you get 5.45 feet squared. All right, so the next one says a windshield wiper blade is 18 inches long. So here's my windshield wiper. It's 18 inches long. It says to the nearest square inch, what's the area covered by the blade as it rotates through an angle of 122? Well, if you think about this, the windshield wiper goes up and then it goes back down, right? This is what they're talking about. It goes up 122 degrees and then it goes back down. They want to know the area covered by the blade. Okay, well, here's your radius. Here's your angle measure. Find the area of the sector. I want you to pause it, and then we'll come back and see if we end up with the same answer. All right, so my angle measure is 122. I plugged it in. My radius is 18. I plugged it in. So in your calculator, you should have taken 18 squared times 122, then divided it by 360. Now, I wanted it as a decimal only, so multiply it by pi, you get 344.9. So roughly about 345 inches squared. All right, so part of the sector is called a segment. So if you take the sector, right, and then you put in a chord here, the part that's formed by the chord and the arc is called the segment. To find this area, you're going to take the whole sector, which was this piece that we just found, and then you're going to subtract this little tiny triangle that it makes here with this chord and the two radii, okay, and you're going to get what's left over. So you're going to take what we just did, the sector, the measure over 360 times pi r squared over 1, and subtract the triangle that you get, base times height over 2. This becomes a little bit difficult because you have to remember how to find the area of a triangle if you don't have necessarily all the parts. So let's take a look. Find the area of the segment L and M right here to the nearest hundredth. So first part's pretty easy. You take the measure over 360 times pi r squared over 1. Then you're going to subtract the triangle, base times height over 2. So this part's pretty easy. I know that it's 120 over 360. I know my radius is 9, so this is pi times 9 squared over 1. All right, so right away I'm just going to figure this part out, and then I'm going to focus on the triangle. This is 81 times 120 divided by 360. This gives me 27 pi. Now let's focus on the triangle. All right, this is the triangle right here. I'm going to put it this way just so that it's easier to work with. I know that this is 120 degrees, and I know that this is 9. I need to do base, I need to do height, and I need to divide it by 2. All right? If I put in the height here, I know that this is 60 degrees. This is a right angle, which makes this 30 degrees. This is a 30, 60, 90. If the hypotenuse is 9, that makes this short side 4.5, which makes this side 4.5 square roots of 3, which makes this whole thing 9 square roots of 3. So let's go over this one more time. Looking at just the triangle here, I pulled it down here. If this is 120 degrees right here, and I put in the height, that makes it 60, so I have a 30, 60, 90. The hypotenuse is 9, which makes the short leg 4.5, which makes the long leg 4.5 square roots of 30, which makes this whole side 9 square roots of 3. So my base is 9 square roots of 3. My height is 4.5, and I have to divide that by 2. If I type all of that into my calculator, I get 35.07. So now all I have to do is take 27 pi minus 35.07, and I get my area, which is 49.75. Remember, it's the nearest hundredth, and then it's going to be centimeters squared. So arcs have both measure, which we were just doing, and then they have length. Okay, we did degrees before, that's the 360 part, and then they have length. If you want to think about length here, let's talk about a circle. The degrees came from the inside, that's why it was area, right? We use pi r squared. The length is the measure from one part to the next. That's going to be part of our circumference. So when I want to find arc length here, it's actually just a fractional part of the whole circle, circumference. So the m over 360 gives you the part of the circle, but this time we're looking for the outer part. So it's not going to be pi r squared like we did in the inside, the area. It's going to be 2 pi r because it's a part of the actual distance around. All right? So if I want to find each arc length, and then in terms of pi and then rounded, I'm going to take a look here. It's asking me for FG. So F to G right here, it tells you it's 134 degrees. Let's use our formula. So it's 134 over 360, the measure over 360. And then now, because it's part of the circumference, it's 2 pi r. So 2 pi, the radius here is 8. All right, so up on top you get 16. 8 times 2 is 16 times 134. Divided by 360, that gives you 5.96 pi. Or when you multiply the pi through, you get 18.71. Both of them are just in centimeters because we're measuring the distance around. We're not measuring area. All right, find the arc length. Give it in terms of pi. So it says an arc with a measure of 62 and the radius of 2. Now, if you wanted to draw a picture, you can. Otherwise, all of the information is given to you in this sentence here. Pause me, figure out what the length is in terms of pi and rounded, and then come back. All right, so the measure is 62. The radius is 2. So 2 times 2 gives you 4. 4 times 62 divided by 360 is about 0.69 pi meters. Then if I want it in terms of hundredths, I have to multiply by the pi. You get 2.16 meters. Now, I know there's going to be lots of questions, especially about the segment piece. I'm more than willing to go over those. Just make sure that you write them down, and then we'll talk about it tomorrow, okay? Have a good day, you guys.